Alrighty, good morning, first period, good afternoon, fifth period. Clearly my throat thing has turned into more than just a sore voice from singing. So what I've done to get you guys the content for today is I'm making a little video right now that the substitute will play during class so that you guys can see exactly what I'm looking for when we're looking at Module 8.5. And Module 8.5 is right here. Our target today is to develop an understanding of the value of the correlation coefficient. And so we've talked a little bit about correlation. We've talked about how a scatter plot could or could not be a correlation. And so what we're going to be doing today is we're going to be looking at it in a little bit more detail. And we're starting to use some metrics that people who analyze data use when they're talking about correlations. To do that, what I want you guys to do is I want you to take your packets from yesterday and I want you to go to 8.5 here, connecting the dots. This is page 23 in the packets. And for this task, it's going to ask us to do a couple different things. It's going to, first of all, it wants us to take the data and graph it on a scatter plot. And then it wants us to use technology. In this case, we'll be using computers. Don't go up and grab them yet. There'll be time for that later. But we're going to be using computers to calculate the correlation coefficient. And so we'll go ahead and start with set A here. And what I want you guys to do is for all of these, in your notebooks, just draw out a basic, a Cartesian plane. We only need the first quadrant here. So draw out a Cartesian plane so that we can graph these points. When we look at set A, what we're going to do is we're going to view this first row here. These are going to be our x values, and our second row is going to be our y values. So when I look at this column right here, and it says 2, 1, what that means to me is that's the point 2, 1. And so when I look at my graph, I'm going to go to 2, 1, and I'm going to graph it like that. And then I'm going to do the same thing here. When it's 2.3 and 1.5, that tells me it's the point 2.3, 1.5. And so that's exactly what I'm going to do. I'm going to go to 2.3, which is about here, 1.5, which is about here. I'm going to try to get as close as I can. And then I'm just going to do the other ones, right? The next one is 3.3 and 2.5, 3.3, 2.5, 3.7, which is getting closer to 4, and 1.9, which is not quite 2. Next one is 4.2 and 2.8. 4.2 is about here, 2.8 is about here. 4.6 and 3.2, 4.6 and 3.2. 4.5, 4.5, so 4.5, 4.5. Whoops, that's actually higher. It's up right here. 5 and 3.7. 5.5 and 3.7. No, 1.7. Geez, that's low. This is not. This one right here doesn't appear to be following the pattern that everything else seems to have this sort of upward motion, but this one, ooh, just takes a break. 5.7 and 4.8. 6.1, 2.7, something like here. And 6.4 and 2.3. And then go ahead and pause the video if you need to give everyone time to create their own. But this is going to, actually I'll stop talking for a second so you can do that. So this is going to be our set A. Okay, so we've done our set A, and I just want to make a couple observations about what's going on with this set A. In general, it appears to have some sort of positive movement. It's not a perfect correlation. Remember we would say like a perfect correlation would be essentially a straight line going like this. It's not that. We have this area down here, which appears to not follow that pattern. But it appears to have some sort of correlation. But how do we compare correlations? And that's ultimately what the correlation coefficient is all about. And so I want to take a second right now, and I want to kind of give you an idea of what the correlation coefficient means. Okay? The correlation coefficient is going to be a number. The correlation coefficient is going to be between -1 and 1. And we call the correlation coefficient R. I am not sure why we call it R. That is a smarter mathematician than me who has decided to call this thing R. But the correlation coefficient is some number between -1 and 1. And so when we look at that spectrum of numbers, you know, if we were to have a completely positive correlation like this, we would say that R equals 1. Likewise, if we were to have a negative correlation, a perfectly negative correlation like this, where it's moving downwards, we have a negative slope, we would say that this R equals -1. But if we had no correlation whatsoever, right, if it was very scattershot, kind of at random, no way of saying that it was anything, we would say that this would have a correlation coefficient of 0. So what we're looking at here when we're talking about correlation coefficients is we're really looking at two metrics that we're looking at. We're looking at, first of all, whether or not it is positive, and we are looking at if it is negative. This is one metric that we're looking at. Is it positive or negative, and what does that mean? Positive correlation coefficient, so anything from a 0.001, as long as it's positive, to +1, means that we're moving upwards. We're moving upwards somehow. Like this might be a less clear but still positive relationship. Whereas negative, if it's between -1 and 0, what that means is we're going to have some sort of sloppy but still negatively moving correlation. So that is one metric that we care about. We care about whether it's positive or negative. And then the other thing that we care about is how close to 1 it is. How close to -1 it is. How close to -1. And for this one, it's how close to +1. And what this means is if the number is close to 1 or -1, it's going to be a stronger correlation. Okay, so closer to 1, -1 means strong correlation. You know, when we're talking about 1, -1, 0.9, -0.9, 0.8, -0.8. As long as it's approaching 1 or -1, we're going to call that a strong correlation. However, if it's closer to 0, okay, whether that's positive or negative, we're going to call that a weak correlation. A weak correlation. Okay? So that means if it's like 0.1, 0.2, -0.1, -0.2, we're going to call those weak correlations. And in fact, if we view it as a number line, like so, you'll see exactly what I mean. So I'm going to draw a little number line in here. Okay. So, this is our number line of our correlation coefficients. Here's -1, and then here's 0, here's +1. Let's go 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 0.1, 0.2, 3, 4. So this is 0.5 right here. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. This is -0.5. Okay? And so whatever our R is on this spectrum, okay, we're looking at two metrics. All right, first of all, positive and negative. But if it's anywhere in here, if it's anywhere in here from the negative 0.5 to the 0.5, we're going to call this weak. However, if it's here or here, if it's closer to our ones, whether it's the positive one or the negative one, either of these are going to be strong. Okay, yellow is strong. Let's do some highlighting, make it clear. Oh, why am I singing? My voice is killing me. Okay, so those yellows, if the number is in those ranges, we're going to call it a strong correlation. If it's in the pink range, we're going to call it a weak correlation. And then likewise, you know, if we go from, if we're anywhere along here in the green, you know, 1, 0.5, these are our positive values, so thus it'll have a positive slope. And if we're anywhere in here, it's from the negative 1 to the negative 0.5. These are our negative values. We're going to say it has a negative slope. So those are the basics of what we're talking about when we're talking about our correlation coefficient. There's a lot to take in there. So give it a look-see. See what's going on there. Go ahead and pause it right now if you need to finish taking up some notes. Then what I want us to do is let's return back to our sheet. It then asks us to use technology, or in this case a computer, to calculate the correlation coefficient. So before you guys go up and grab your computers, give me a second to show you what this looks like. First of all, we can kind of predict what this value is going to be, right? I kind of led you guys. I kind of said it's a little positive, but would you consider this a strong or a weak positive? You know, I kind of view it as it's not a straight line. It's not completely scattershot, but I don't think it's the strongest thing in the world. So I'm not sure if this is going to be weak or strong, but I'm putting it somewhere around that 0.5. Because while I see a positive correlation, these three dots right here really break it up. You know, these guys really make it so that it's not the strongest correlation I can imagine. So go ahead and take a guess. Do you think this is going to be like a 0.3? Do you think this is going to be a 0.7? You know, where in there do you think that's going to be? It's clearly a positive relationship. It appears to be moving up, I think. Yeah, that's positive. But let's find out. You know, the calculation for what that correlation coefficient is, trying to find that R value that tells us how positive, negative, strong, and weak it is incredibly hard to do. And so luckily, we've made some tools to help us do that. So I'm going to go ahead and pull that up real fast. We're going to move away from this. And so to find the tool, all you have to do is you have to go to our website, clackamasmiddlecollege.org. You are a student. You are taking classes. This happens to be a math class. And this is Algebra 1 with your beautiful teacher, Victor Castorini. And I have right here 8.5 correlation coefficient calculator. All you have to do is click on that link. It'll pull you into this. You see this crazy equation right here? This is actually the equation we're using. Now, I'm not going to teach you guys all of it. I'm not sure I know all of it. It's been too long since I've taken a stats class. But what this does is this calculator allows us to do exactly what we want to do. It's going to give us that R value. See, it says calculate R button, and that's all the way down here. So what we're going to do is we're going to just re-enter that chart so that our X values line up with our Y values. So our first point was 2, 1, right? Our second value was 2.3, 1.5. So you got to make sure that they line up like this, right? The 2, 1, 2.3, 1.5. Now, I don't want to go back and forth. So what I'm going to do is I'm going to do all my X's first. 3.3, 3.7, 4.2, 4.6, 4.5, 5, 5.5, 5.7, 6.1, 6.4. And then I'm going to do all my Y values. So I already did 1.5. That was my second one. So 2.5, 1.9, 2.8, 3.2, 4.5, 3.7, 1.7, 4.8, 2.7, 2.3. Okay, and I make sure that they're all right, give them a little once over, and I'm going to hit my calculate R. We're going to calculate R and see what it does here is look at this scatter plot. Hey, that looks familiar. I think I did something like that. Theirs is nicer, of course, because they're not as sloppy as I am, but that's exactly the same value that we were looking at. Okay? It has all the metrics listed, but here's what we really care about. It gives us the R right there. And so that's the value that we care about. You know, when we see that R is 0.4966, okay, let's go back to our notes. So this R value for set A, our correlation coefficient is 0.4966, okay, 4966. I was pretty close. I said it's somewhere around that 0.5. Like, it's not strong, it's not weak. It's just a hair to the weak side. So we would say that this is a weak positive correlation. All right? So our correlation is weak positive because it's in our weak zone, right? It's closer to 0 than it is to 1. But it's still positive. So we know it's moving upwards. We have a positive slope. All right? So that's all cool. One of the things that you're going to be asked to do on your homework then is there's one more piece of vocabulary we got to talk about. Let me move this over so we can talk about it. And so you'll be asked to estimate the line of best fit. Okay? And what does that mean, right? Oh my gosh, Victor, all these terms. What are you doing to us? Making me learn? This is crazy. So the line of best fit pretty much is asking us, okay, so if we were to summarize this entire scatter plot with a line, what would that line look like? And when I look at, so like, if we can imagine if there was a line that was equidistant to every single point, what would that look like? And so when I look at this thing, it's going to be positive, right? So I know it's not going to be negative like this. It's got to be positive. But where's the best fit going to be? And so when I think about this, you know, I think it's going to be something like this, honestly. You know, here I have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6 above, 5 below, maybe a little something like this. Okay? I would estimate that the line of best fit would look something like this. So if we were to continue this pattern on forever and ever, I would imagine that I would have dots that kind of jumped around both sides of that blue line, above and below. Now, again, this is an estimation. It may or may not actually be the line of best fit. There is a way to calculate the line of best fit, but this is just a way to kind of wrap our brains around what that might be. You know, we can imagine here that there's some line going through there that works. And actually, if I remember correctly, I thought this gave us the line of best fit somewhere in here, but I don't recall. It's been a while since I've used this program. Anyway, that being that's what you're going to be able to need to do to get all this stuff done. When we're looking at the homework for today, though, I want to talk to you guys about, whoops, all this stuff. Where's the thing that I actually want? There it is. What I want you guys to do is in your notebooks, I want you guys to recreate this. I want you guys to do the scatter plots for B, C, D, E, F, and G. Okay? And that's going to take some time. It is. But what I really want you guys to be able to do by the time we're done here today is exactly this: develop an understanding of the value of correlation coefficients. Some of these are going to be positive. Some might be negative. Yeah, some might be negative. I'm not sure. Some are negative. Some are positive. And I want you to kind of be able to see what kind of patterns of scatter plots are going to cause them to be positive and negative. So you have to do a few graphs, 1, 2, 3, 4, 5, 6, 7, to develop those patterns. And then when we look here on the back side, it asks us to use data set in A, keeping the same x values, modify the y values, to try to improve, in this case, the correlation. Because remember, in data set A, we had a correlation coefficient of 0.4966. And so what I want you guys to be able to do here is to adjust some of those numbers, maybe get rid of these low guys, and see if we can improve that correlation coefficient to something more positive. And it'll ask you to do the same thing, make it weaker, make it negative, etc. So you're kind of getting your hands dirty playing with some numbers to see how they relate to the correlation coefficient. Homework-wise, nothing too terrible, I feel like. You're going to predict the line of best fit, you're going to draw it in, and it's going to ask you the equation of that line. That's not terribly difficult. This one's going to ask you to rank them, what's strong, what's weak, what's positive, what's negative based on these scatter plots, and trying to estimate their correlation coefficients. And then these ones are a little bit of review. It's mostly just playing with slopes. Comparing slopes of lines. I want you to make a larger slope, so a bigger number, which means it's going to be more positive. Smaller slope means a negative number. It's going to be a more negative slope, etc., etc. And that'll be it for today. The bulk of the work is really just using the computer program and graphing by hand. Make sure you graph these by hand. I know that the program does a cute little automatic bing, 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 puts the graph up for you, but I feel like a lot of us still need a lot of work plotting our x, y coordinates. So I want you to graph all of these by hand in your notebooks, and then check it with the computer program to make sure that you're doing it correctly. I know it's tedious, but we got to be able to see each of these things and what they look like, through our own work. And being able to create those graphs. I also want you guys to predict what the correlation coefficients might be. I think you'll be able to do that by the time we're done with this today. Tomorrow is our field trip. Thursday is our quiz. What I really want you guys to do is make sure you come Thursday morning with some questions. The quiz will not be very long, as we only covered 2 sections this week, but bring those questions so that I can cover anything that maybe I wasn't able to cover in this video, because I want you guys to be as successful as possible. All of that said, I'm going to make some copies of this note sheet so that those of you that need a little bit, that need a handout can use it. All right, guys, take care, be good. Essen, don't put your backpack on 5 minutes before class, and everybody else, have a good day.